And we're back with another PicoCTF challenge, this time vault-door-6. This vault has an XOR encryption scheme, and the source code is here. So I've already downloaded that. And then the hint is if X, and this is a sign for XOR Y equals Z, then Z XOR Y equals X. Write a program that decrypts a flag based on this fact. And so it would be really helpful if we talked about XOR just quickly. So I'll go to this presentation that I have. So first, XOR is a logical operation. We're used to arithmetic operations, things like multiplication, addition, subtraction. Logical operations, the word logical just means it operates on true and false values. The reason why this is useful for a computer is true and false is very similar to 0 or 1. Something is either on or off, true or false. So this is a bitwise operation, and we have a truth table here. And a truth table describes the operations of a function. So given an input A and an input B, when we apply the XOR operation on them, and the values are both 0, we get a 0. When one is on and the other one is off, we get a 1 out in both cases. And when they're both 1s, we get a 0. And it may be helpful to you to see this Venn diagram here where we show an exclusive OR. So red means the function will give us a 1, and white means it won't. So what this is showing you is, and these circles are A and B respectively, when a value is in, or here's how I should put it, when only one of them is on, but not both, this intersection is when they are both on, you get a 1. And if neither of them has the value in it, then you don't get anything. So it's exclusive. It must be in one and only one of these two. And this will make more sense as we go along. So it's represented a few ways. The first way you'll see, you will not find this button on any keyboard. So you'll see this in math textbooks, this plus with a circle around it. Typically in computer programming languages, you'll see it with the caret. So that would be A XORed with B. And then sometimes you'll just see it explicitly spelled out like this. What are the benefits of XOR? Why do we care? Well, first, it's super simple to understand, as you'll see in just a minute. It's cheap to compute, and it's useful in crypto. So the one-time pad is something that I'll talk about later, but all you really need to know about it now is it's truly unbreakable cryptography, assuming you do it right and you keep the key a secret, and it's incredibly simple. So XOR finds uses in all kinds of cryptography. And the one-time pad is just a very good example of it. So XOR has a very interesting property of canceling itself out. So for example, multiplication and division cancel each other out, or addition and subtraction. So here we see 10 times 1 over 10, so a tenth, plus then some additional work. Well, we all know these two cancel, so the 10 and the 1/10 will cancel, which is what you're seeing in this terrible animation, and the term disappears. So you're going to see the same thing with repeating an XOR cancels the XOR. So for example, A XORed with B gives us this C value. C XORed with B gives us A. So what does that actually look like? Well, C we defined over here as A XORed with B. So you can see we're expanding the term here. So A XOR B equals A. So what's happening is just the canceling of B. And similarly, if we wanted to instead get what B was, we could have done A XOR B XOR A equals B. Again, this will make more sense as we go. So what I'm going to do is I'm going to take these two strings of numbers, and you'll notice they're exactly the same. And I'm going to apply the truth table that we saw earlier, and I'll just go bit by bit. Like we said, it's a very simple operation. So we have a 0 and a 0. So we look at a truth table. A 0 and a 0 gives us a 0. A 1 and a 1 we see at the bottom gives us a 0. A 1 and a 1 gives us a 0. Okay, you get the idea. So this all zeroes out. And this should make a lot of sense because we talked about how things could be in one or the other, but not both. Now we're looking at two things, A and B, where A and B are exactly the same. So there is no exclusivity to this, if that makes sense. These circles would be right on top of each other with a perfect intersection. So let's talk about a cryptography example. So we have Annie here, and we use Annie because point A is where the message is starting. And then we have Bill, point B. Annie wants to send a message to Bill. She has this message that we're calling secret, that's the text, and she's going to XOR it with her password of password, and she's going to get out encrypted bytes. And the reason I'm not showing this is because it's actually unprintable characters that we get. So we have the word secret, which we can represent in ASCII as the following bytes. So you'll see S is this series of 1 byte or 8 bits, then E, C, okay, you get the idea. Now we're going to XOR that with password, where this first byte is P, this next byte is A, this next byte is S. Okay, so if you were to go through this, you would see this all works out, just going bit by bit, and you get this value in red, which is the encrypted bytes. Now you can send that across to Bill, and anyone who sees this, they will not be able to figure out what the actual password is because they don't have, or what the secret is because they don't have the password. So this just looks like a string of gibberish. When Bill receives this, since he knows the password, he can reapply password and perform this XOR, and you end up with secret. So that's what we're going to be doing here as I switch back to Kali. As we look, so we've seen 6 vaults now, and we know that the main is always the same, and it's uninteresting, it just takes an input. We're interested in check password, and we want to make sure this returns true. So we first see that we need this to be 32 bytes of input. We get those bytes, and then we have this m bytes array that's defined. And we can see that we're looping over all 32 bytes, and this is what we passed in. We are XORing that, so XOR each byte we passed in with hex 55, and we're subtracting the corresponding value in this m bytes or my bytes array. And then we check, and if it doesn't equal 0, we return false, meaning we fail the check. So we want this to return 0. So what that means is when we XOR whatever we passed in, it has to exactly equal this. So what that means is we can XOR each of these, and we'll find the value that we have to pass in. So we could do one by hand quickly, and then I'll show you how I did it programmatically. So I have a programming calculator here, and I'm using the programming mode, and we will put in 3B. Oops, got to change it to hexadecimal. So 3B, and we are going to XOR that with 55 and see what the output is. And that is 6E, or 110 in decimal. And let's look up in an ASCII table what exactly that is. What is 110 in decimal? And that is an N. So you could go through this one at a time, performing this operation, but that's kind of tedious. So let's actually write a function, and what it's going to do is it's taking those bytes. I just rename it to encrypted because this is the encrypted password, or the encrypted flag. Then we're going to loop over encrypted, and for each byte we will XOR it with 55, and we get an int out of this. So one of the important things here is, remember again, computers just see numbers, they see binary, but how we treat those numbers affects what you eventually see. So I will turn on all this logging that I have just so you can see the transformations that happen, and then we'll get the solution. So at the bottom, you're going to see that we took first each of these values. That's what you see leftmost. Here it's in hex, here it's displayed in decimal. We XOR them and we get a new number, and then we interpret that number as an ASCII character, which is the same as just looking it up in that table that you saw earlier where I was doing it manually, and you can see it's not underscore much harder than XOR. Okay, cool. So let's clean that up so we can submit our flag. So I'm just eliminating the different guys that I had in here, the output statements, so we don't have any of that extra noise. I'm going to copy this, and oops, Control-C doesn't copy in this. I will right-click, copy. I'm going to create a new file, and I'm going to show you guys a little cool trick. So I've got this annoying spaced output, right? And I just want a single line. So what I'm going to do is Control-F, and I will turn on regex mode, so regular expressions, and I want to match a new line. So the slash means it's a meta character, and /n means it's a new line. So we've matched the new line. You can see that's the highlighted portion, and we want to replace it with nothing. And we're going to do that for all the ones we found. And there's our flag. So I'll now go over and submit it, and we'll see if we got it right. Perfect. Hopefully you found this helpful. If you did, you can help me out by leaving a like, comment, subscribing, etc. Thanks. Bye.